Well, let's take another look at a torus. Here's a nice one. This one is colored. It's what is known, involves what is known as the coloring problem. There are 7 colors here, and each one touches every other color. It's part of a problem that's known in mathematics as the mapping problem. And it's characteristic of surfaces that you can distinguish them by the number of colors required to map countries. Now, the surface of the sphere requires only 4. And I could indicate it, a 4-color map, for instance, could be drawn this way. Now there's 1, 2, 3, 4 areas in that simplified map, and each one is touching every other one, so you'd have to have 4 colors to distinguish them. I won't take time for it here, but the torus, which is circular in 2 different ways, do you see why? It's circular this way, but it's also circular this way. Those 2 different circles give access to itself in 2 ways. If you thought of 4 people sitting around a table, with the torus, they can also reach under the table. You could do sneaky things in this universe made in a toroidal fashion. You could break the law. Well, that's exactly what happens here. The creatures that are evolving get down to this point where there's total determinism, and they're bound in, but they manage to get around the law. That's what an inventor does. But the way you get around the law is to recognize it. Once you can see what the law is, then you can take it into account and make it work for you. And this is perhaps the basic distinction between a universe that's alive and a universe that's just clockwork according to the old classical picture of determinism.